What again is the derivative of a function? Given a function defined by y is equal to f of x. The derivative of the function, which is f prime of x, that is how you read it, is the limit of f of x plus delta x minus f of x as delta x approaches 0. This is just your limit of change in y over change in x. And then again, to dispel your dread, if ever you feel kind of dread when it comes to getting the derivative, I wish to remind you that the derivative is just the slope of a line. It's the slope of the tangent line. And slopes of lines are basic to you. You came to learn about slopes way back in grade 7. And from then on, okay, the topic of slopes often crops up with in many of your classes in math. So this is just about the slope of the tangent line. Then again, of course, the derivative of a function at a point does not always exist, for the same reasons that the limit of functions as x approaches a point does not always exist. But in our videos, we will focus only on functions that are differentiable at a point. Okay, I almost forgot that term, differentiable. Okay, differentiable means it has a derivative at the point. That is the meaning of being differentiable. So we have the three-step rule to get the derivative, and the purpose of this is to organize orderly your solution. If you had been doing exercises like this, getting the derivative of a function at a point, then you now know that this is not easy to do. Well, for one, it's tiring. It tires your hands easily because many students today, their hands no longer have the muscle endurance to write wrong solutions. And so many students just get lost or they just give up along the way. Halfway to the finish line, they give up. And so the purpose of the three-step rule is to organize your solution and to save some writing, okay? You don't have to write always the symbol limit as delta x approaches 0. You don't always have to write that. You will append or affix this symbol at the third step only. First, simplify. This is delta y, okay? And then whatever would be the result of your first step, you divide it by delta x. And then you get the limit of the result in your step 2 as delta x approaches 0. Find the derivative of a function at the indicated point. Get the derivative of f of x is equal to e to the x when x is 0. You're familiar with this. This is your natural exponential function. And when x is 0, okay, when x is 0, y is equal to 1. Okay, so e to the 0 is just equal to 1. This function contains the point with coordinates 0, 1. And we will draw a line that is tangent to the curve at that point. What is the slope of that tangent line? And what information does it give us? It is giving us the rate of change in y over change in x. But not an ordinary rate of change. It is telling you the instantaneous change in y over change in x of your function when x is equal to 0. It is telling you how fast is our function changing when you have changes in x. So again, the derivative of our function when x is equal to 0, you read it as f prime of 0. That is the slope of your tangent line. Step 1. What is f of x plus delta x minus f of x? So it's just equal to this. E to the x plus delta x minus e to the x. So students who are doing this for the first time, they cannot quite reconcile this and this. F of x is e to the x, okay? So when it's f of x plus delta x, you will replace that by x plus delta x, okay? We now go to step 2. Let us divide the change in y by change in x, okay? Now look at this. E to the x plus delta x minus e to the x divided by x is equal to this. Why did this become this? E to the x times e to the raised to delta x. Well, it's like something like this. A raised to n times a raised to m. That is equal to a raised to n plus m, okay? And so we just factored e to the x plus delta x into 2 factors. E to the x times e raised to delta x. And what do we do next? Well, what I did here is I factored out a common factor. E to the x is a common factor in these 2 terms. And so what is left here, when you factored out e to the x, what is left here is 1. So this is equal to e to the x times e to the delta x minus 1 divided by delta x. We shall now go to step 3. And in step 3, we will evaluate what is the limit of this. What is the limit of this when delta x approaches 0? Applying our theorems on limit, this is a product of functions, e to the x times this one. And so we can write it in this way. Okay, so what is the limit of e to the x times e to the x minus 1 over delta x as delta x approaches 0? So this one, delta x, where delta x is approaching 0, will affect only this one. Okay, and what is the limit of this? Okay, what is the limit of e to the delta x minus 1 over delta x as delta x approaches 0? This is equal to e to the 0 is 1 minus 1 over 0. So this is equal to 0 over 0. So this one is an indeterminate form. And this is not the first time we are seeing this. We saw this when we were talking about the limit of exponential functions. We saw this. We saw this as a limit that gives an indeterminate form. And we were able to resolve this. We were able to find out that the limit of that, the limit of e to the x minus 1 divided by x as x approaches 0 is just equal to 1. Okay? And so this answers our question. So the derivative of our function with respect to x is equal to the limit of this as delta x approaches 0 times the limit of this as delta x approaches 0. And that's just equal to 1. And so that's going to be e to the x times 1, which is e to the x. So, what is the derivative of your function when x is equal to 0? That is the same as what is f prime of 0? So f prime of 0 is this. E to the 0, it's equal to 1. And so again, going back to our function, the green curve is the graph of your natural exponential function. We have a line that is tangent to the curve at point A. That is when x is equal to 0. And how do we interpret the slope of the tangent line? So f prime of 0 is equal to 1. That is telling you that the instantaneous change in y over change in x is equal to 1.